Welcome to the lesson on the role of motors in battery electric vehicles. By the end of this lesson, you will be able to explain how gasoline engines and electric motors are different. You'll describe how electric motors actually move electric vehicles. You'll identify how motors change vehicle design, including space and balance. You'll explain how electric vehicles help the environment, and finally, you'll describe how transportation may continue changing in the future. What do you think is happening under the hood when a car zooms past you on the highway? Inside a gasoline car, fuel is burning very fast. Gasoline mixes with air and creates tiny explosions inside the engine. Those explosions create hot gases that push metal parts back and forth. That movement spins a shaft, which turns the wheels. So every time a gas car moves, controlled explosions are happening inside the engine. Now that we know explosions are involved, let's break down how that actually happens. Gas engines repeat 4 basic steps over and over. First, fuel and air go into the engine. Second, the mixture gets squeezed tightly. Third, a spark causes a small explosion. Finally, the burned gases leave. This happens thousands of times every minute to keep the car moving smoothly. So if gas engines burn fuel, how do electric cars move instead? Electric vehicles do not burn fuel at all. They store electricity in large batteries. That electricity flows into a motor, which starts spinning. When the motor spins, it turns the wheels. There are no explosions, just smooth, quiet motion powered by electricity. Now that we've seen how both systems work, let's compare them side by side. Gas engines burn fuel and produce exhaust smoke. Electric motors use electricity and produce no tailpipe pollution. Gas engines have many moving parts, so they need more maintenance. Electric motors have fewer parts and are much quieter. Now that we understand the main motor moves the car, let's talk about the other motors inside a vehicle. Electric vehicles have one large motor that drives the wheels, but they also have many smaller motors that run things like power steering, windshield wipers, power windows, seats, cooling systems, and climate control. And here's something important. Gasoline cars also use small electric motors for these same features. So wipers, windows, and seat adjustments work in similar ways in both types of vehicles. The big difference is this. In gasoline cars, the main movement comes from a fuel-burning engine. In electric vehicles, the main movement comes from an electric motor. Now that we understand how electric motors work, let's look at how these motors change the way electric vehicles are designed. Because electric motors are smaller than gasoline engines, designers don't need to build a large engine compartment in the front. This opens up more space inside the vehicle. Some electric cars even have storage space in the front, called a frunk. So the motor doesn't just move the car, it changes how the whole vehicle is built. One major design change happens under the vehicle. In electric cars, the heavy battery is placed low under the floor. This lowers the vehicle's center of gravity. When weight stays lower, the car feels more stable and balanced. It handles turns better and is less likely to tip during sharp movements. So placing the motor and battery differently actually improves safety and performance. Another design advantage comes from shape. Since electric vehicles don't need a large engine in the front, engineers can design smoother shapes. This reduces air resistance, also called drag. When there's less drag, the vehicle needs less energy to move forward, which increases driving range. So motor placement doesn't just change space, it also improves how efficiently the car moves through air. We've just seen how electric motors change vehicle design. But now let's look at something even bigger, how they affect the environment. One major benefit of electric vehicles is that they produce no tailpipe emissions. That means no smoke or exhaust coming out of the back. Gas vehicles release gases that can pollute the air, especially in cities. Electric vehicles don't release those pollutants while driving. However, it's important to remember that electricity still has to be produced somewhere. If the electricity comes from cleaner sources, the environmental benefit becomes even greater. Let's talk about energy efficiency. Electric motors are very efficient at turning energy into motion. Most of the electricity goes directly into spinning the motor. Gas engines, on the other hand, lose a lot of energy as heat. If you've ever felt how hot a car engine gets, that's wasted energy escaping as heat. Because electric motors waste less energy, vehicles can travel farther using the same amount of energy. That means better efficiency and smarter energy use. Efficiency is important, but where the electricity comes from matters too. Electric vehicles can be charged using renewable energy sources like solar panels, wind turbines, or hydroelectric power. When clean energy is used, electric vehicles reduce pollution even more. This creates a powerful combination, an efficient vehicle powered by clean electricity. That's one reason many experts believe electric vehicles are an important part of reducing pollution in the future. There's another benefit you can actually notice with your ears. Electric vehicles are much quieter than gasoline vehicles. There's no loud engine noise or roaring exhaust. This reduces noise pollution in neighborhoods and cities. Quieter streets can make communities more peaceful and comfortable. So electric motors don't just improve air quality, they also improve sound quality in our everyday environment. We've seen how electric motors work and how they benefit the environment. Now let's look ahead and explore the future of transportation. Transportation is changing faster than ever before. Engineers and scientists are developing cleaner, smarter, and more efficient vehicles. Electric cars are becoming more common, technology keeps improving, and the way we move around cities is evolving. The vehicles you may drive in the future could look and behave very differently from what we see today. Because technology keeps improving, more electric vehicles are appearing on the road every year. Charging stations are being built in more places, making it easier to recharge. As batteries improve and production increases, electric vehicles are becoming more affordable. Many companies are investing heavily in electric vehicles because they see strong demand growing worldwide. What was once rare is quickly becoming normal. One major reason electric vehicles are improving so quickly is battery technology. Modern batteries last longer and allow vehicles to travel farther on a single charge. Scientists are constantly working to make batteries charge faster, weigh less, and store more energy. As battery performance increases and costs decrease, electric vehicles become more competitive with gasoline vehicles in both range and price. At the same time, vehicles are becoming smarter. Some vehicles now use sensors, cameras, and computers to help drive themselves. This is called autonomous driving. These systems can help prevent accidents, assist drivers, and potentially make roads safer. In the future, self-driving technology may help people who cannot drive, such as the elderly or people with certain disabilities, travel more independently. In addition to driving themselves, vehicles are also becoming connected. Smart vehicles can connect to the internet and communicate with traffic systems. Some vehicles can even share information with nearby vehicles. This helps reduce traffic congestion, improve navigation, and increase safety. Instead of each car operating alone, vehicles are beginning to function as part of a connected system. As electric vehicles become more common, they also connect to something called a smart grid. A smart grid is an advanced electrical system that manages energy efficiently. It can balance electricity from different sources, including renewable energy like solar and wind. In the future, vehicles might even store energy and send it back to the grid when needed. This creates a more flexible and resilient energy system. Finally, engineers are improving transportation by using lighter materials. When vehicles weigh less, they require less energy to move. Materials like advanced aluminum, composites, and high-strength alloys help reduce weight while keeping vehicles strong and safe. By combining lightweight materials with electric motors and better batteries, engineers continue to improve efficiency and performance. Let us now summarize what we have learned in this lesson. Gasoline engines move vehicles by burning fuel, while electric motors use electricity stored in batteries. Electric vehicles are quieter and more energy efficient. The placement of motors and batteries changes vehicle design by improving balance and creating more interior space. Electric vehicles also produce no tailpipe emissions, which helps improve air quality. Advances in batteries, smart systems, and lightweight materials are continuing to shape the future of transportation. Electric motors are playing a major role in how vehicles are evolving today and in the years ahead. Thank you for your attention.